So good morning again. Thank you for. I know it was a last minute change of the class. There's somewhere I need to rush to later on, as early as maybe 8:30 or 8 something. That is why I was requesting that we come to this class this morning, earlier than the normal days that we have been doing. So previously we did the gas laws. We have done the gas laws. We have done some of the calculations that touches on gas laws. Immediately, the second topic after the gas laws now is the mole. Now, of course, the introduction of the mole, I'm using the KLB, but most of the, I'll be switching between, I have three, my notes, my tailored notes, that is very short. We have, this one is the KLB book, and I said we can use the KLB. And then, of course, also we have the top notch, which have very good questions. So we'll be switching between mainly the KLB and the top notch, so that we see what you're going to handle. Now, when you're in Form 1, I don't know if you still remember when you're in Form 1, there was a topic in physics where we were talking about the measurement. It was measurement 1, and then we have the measurement. Now, in one of the measurement that you're talking about, I mean, we have 7 quantities of measurement. So one of them was temperature, which you said was Kelvin, which we had. The reason I'm touching on temperature is because it was the immediate predecessor before we started this topic. So it was temperature where we said Kelvin, we have luminosity, which is intensity of light, and the rest. One of them, one of those measurements, international measurement, was the mole. So the mole, we said, is used to measure the amount of substance. We even mentioned that it is the amount of substance that I say it is the mole, the SI units now. So we said amount of substance is the we are measuring the amount of substance using the mole. Now, the actual mole that we are talking about is this one. It has not changed anything. So we are just continuing. So we are saying the mole that we are saying is actually, if somebody could remember, I normally tell students they could recall, is the one that we are using to measure the amount of substance. Of course, now when we are talking about chemistry, will be very specific about that amount of substance. Very specific. We are going to specifics now, but in universally, or for the universal purposes of definition, the mole is the unit that is used to measure the amount of substance. I don't know if you recall. Do you recall those? I know. I don't know if, but I think it was physics was compulsory. Was it compulsory in Form 1 for all of you? Because you normally teach this in Form 1, and it is measurement. I don't know if it is Maura. Did you do something like this one in Form 1 previously? Before even what you're saying, amount of substance, and then we have the units being the mole. I don't know if you recall something like that. We had where we have current, we have amperes. What else? There are around 7.
Yes.
Yeah. So I know students normally say it is the first time that they're seeing the mole, but actually it was mentioned somewhere. But because now you're young and maybe you're not really interested in that, you will say it is the first time that you're seeing them all. Now, there's this thing that people normally talk about, and I think it is a lie. I want to demystify that myth. Now, we have this myth that they normally say, especially for students who are not yet introduced to the mall, where they are told that the mall is actually a very tough topic. Now, I normally consider the first two topics in Form 3 to be the easiest topics. Here are my reasons. You will see as we continue. Now, the gas laws, we are only having very few definitions, which I think the definitions are only around 3, which is actually the laws that we are going to mention. Those laws that we mentioned. Now, in the mall, and then we have calculations. If you can remember, kama unaweza kumbuka how to state the law in the gas laws, and then you can come up from that law, you come up with the formula, and then you do the calculation, which I normally find it very easy. Now, in the mall, there is only only one thing that you're supposed to know. The definition of the mole, that is only the definition that we need actually in this topic. Now, number two is the formula of calculating the mole. Now, that formula is the one that will cut across. That is from the beginning of definition mpaka mwisho, mpaka summary is the same formula. Now, this formula again will be used. Now, I know we'll be having what we call the empirical formula, the molecular formula, but still, if you do not understand the first part, which you are going to do today, you'll have problems solving those parts now. So it is very, very important for you to be very keen when we start here, because whatever we are going to do will be affecting everything that we are going to do. Of course, we might have to do a dry practical so that we see. So I'll give you a question that has a dry practical, and then we do the calculation so that we see how it is done. Now, as we prepare for the actual practical to be done, we'll just be doing simulations. I can open my PET account so that we use that one for our simulations, online simulations. Just uone tu venye vitu zinafanya. So let us just introduce that one for today. So I'm saying this one is one of the easiest topics. You just have to begin, especially during the introduction, because during the introduction, it is what will help us across. It will help us all through this topic. So usipojua the introduction part, where we have the Avogadro's constant, where we have the number of how to interconversion between the mass, we have the number of moles, the RAM, or what you call the RFM. RM is the relative atomic mass. We'll be talking about that one. So this one now, by the end of the topic, so we can even have this one. I'll not share the other notes. So I said if you have KLB, the reason I normally use KLB most of the time to teach is because most people can come in contact with the KLB rather than the other book. And I say the other time, if you don't have any other book in chemistry, physics, and biology, don't be worried. As long as if you have only KLB, you're good to go. That one can still give you marks. So by the end of this topic, so we have some of the objectives and some of the goals. Let me just put it that way. So we are supposed to define the definition of moles, and then in relationship to, and its relationship to RAM. This one now is the RAM I was talking about. And then we have interconversion. I was saying interconversion of mass to moles and vice versa, which is moles to mass. So mass to moles and moles. That one actually is a kwanza. The A and B is something that we are going to use more oftenly than you may think. We'll use this one kwa empirical formula, kwa molecular formula. Hata tukifanya the practical part, we'll still be using this. That is why I'm saying it is very important. So we'll be using the use of data to determine the empirical formula, the molecular formula, and the rest. So that one is very important. Now, the definition of terms, you'll find that the definition of terms that we're going to talk about, the concentration, the molarity, and the dilution of a solution, actually they are the same. What we'll be talking about only is you are changing, maybe. We are saying we are changing a very small part of it. Let me just say that one instead of giving you what will be happening. Now, preparation of molar solutions. So preparation of molar solutions, again, we'll be dealing with the math. So that is what I'm saying. If you don't know, man, the first two, A and B objectives, are so very important that I would advise you to really dwell on that before you continue to the lower part. Yeah? So we'll be defining and preparing that one. Titration and solving of the problems. Now, this one is where we'll do the dry practical, because most of the time maybe we might not meet, but I'll do a simulation. I hopefully we'll do a simulation, maybe even one or two, which a simulation actually normally helps us in it is like we are doing the practical, but now the computer is helping us. I'm saying add maybe some few centimeters of this liquid, for example, sodium hydroxide and HCl, add 2 drops of phenolphthalein indicator, and then now titrate until the color changes to. That one is the simulation. We just instruct the computer and it gives us the values. But now our work will be to solve now, to calculate, do the calculation. So I think we'll try that one. We have writing formulas. So writing formulas again, I said the other time while we were dealing with gas laws, nilisema it is very important for the students to know how to write the chemical formula of substance, not the word formula. Nilisema it is very important for you to know how to write the formula. Sasa ndio hii tena imetufikia. Of course, ionic equations, we'll be discussing about that one more. And I think there is a place, of course, we'll also discuss the ionic equations. And ionic equations is so dangerous that I fear for you in the exam if you don't practice more. There's something about this, let me just underline that one. There's something about these ionic equations, which I think we'll deal with it a lot. I will give it a lot of time. We can even give the all 2 hours to write ionic equations, because ionic equations is not only affecting the mole, it is affecting us all the way to Form 4. We even have the, what in salts, we have the ionic equations. I think we did those ones. In rates of reaction, we have ionic equation. So it is something that will be, and it is a lot of marks. It is so many marks. I don't want us to miss that one out. Now, after that, we go to defining molar gas volume and atomicity of gases. Now, atomicity of gases, we mentioned it somewhere else. It has been done in another class. I don't know if we have done that topic yet, but it will be mentioned again in another another class. So again, it is very, very important for us to know the meaning of atomicity. I think we did the atomicity of acids and bases somewhere. So it is the same thing. It is the same thing. We will be just touching on something small. We are just changing a very small bit of it. Now, Avogadro's, they're studying the Avogadro's and the Gay-Lussac's law. That law normally confuses students. I'll tell you with what law, and then we'll also state that one for the sake of that time will be in that. It is a different topic, but students, it is not the first time I've gotten students stating a Lussac's law using another law. So I don't know if it is the name that they're almost, but the names are different. But students normally get to, and then we have now to carry out calculations on molar gas volume. This one is very interesting. Actually, this one is very interesting. So we are still going back to what I think somebody had asked about that one. We have the standard temperature and pressure and room temperature and pressure. So STP and RTP, but this one now is what we call the molar gas volumes. The volumes at that particular temperature and pressure will be different depending. I hope I'll be really keen. Now, something else that I have to say about this topic is when we are solving questions, even if I have displayed the question and I'm solving it, I would advise you to also try the same question that I have tried, but actually practicing it. Ufanye venye nafanya, hata mimi, hata wewe unafanya. Nikifanya, wewe pia unafanya. That will help you understand it more, ama uishike more. Yeah. If the more you do it, it gets better. It gets better always. That is what I normally say. As you continue doing, it gets better. So it is very important for us to understand. This one again, I'm saying is the KLB. I think I shared. Did I share the book? Yeah, I don't know if I shared the book. But if I didn't, I'll share my notes. I'll share my notes. The KLB. The top notch. I think I shared the top notch because we were doing it we were using it to solve some questions. So I'll still share that one. And then I think I'll also share the questions. I think I got the questions. I don't know. I'll confirm. For the form 3, I had shared the form 4, but if you don't have it again, unaweza uliza tu kwa group, it will be reshared. Or if you came in late after we have shared, there's no problem, it will be reshared again. So the mole we said is a counting unit. Actually, now the reason I wanted the KLB is because of the objectives. It is very good. It has very good objectives. The others actually don't have objectives. But I will not be doing in the KLB. The KLB has so many explanations that I normally fear that students will run away from class if you use it, if you explain everything. So we normally summarize. So I normally say the mole is a counting unit. It is a counting unit to determine the amount of substance. Now, what is the counting unit? a counting unit. Now, English is normally very good with counting units. Yeah, we have, instead of saying umeona elephants 30, that is a lot of words. English will tell you, please say we have, I don't know, a herd or something, a herd of cattle or something, of elephants. That is, so that one is the counting unit. We are bringing, instead of saying now you have 100 kilos of something, you say, you give it a specific name. Yeah. Now, for example, 12 bananas, in this case, we normally say 12 represent a dozen. Is it a dozen? So instead of saying I have 12 bananas or I bought 12 bananas, unasema you got. Another thing about bananas, in English, you normally say a bunch of. Yeah. So it summarizes, inarahisishia kazi mtu. Yeah, let me just use that word. Inarahisishia kazi mtu. Instead of saying weenda hesabu or go and count how many bananas or go and weigh, I'll just say, if it is 20 bananas, I'll say you have a bunch of bananas that you dropped it in your house. Which, so if I was to deal with now moles, I'll say I have 2 moles of bananas. Yeah, for example, that means the 2 moles represent the bunch. So when you'll be in the mole, we'll be saying, instead of saying you have 300 grams of sodium hydroxide, I can say I have 2 moles. Yeah, or 1 mole of. So it is a counting unit. Now that counting unit is very specific about something. So I just wanted to tell you about. Should you come? If I'm moving too fast, please say something. So when you talk about a dozen, so yeah, we are saying, instead of counting specifically 1, 2, 3, or physically, we know that a dozen is 12. What a 36? We have a crate. Instead of saying now you have 30 eggs, nasema crate moja ya mayai. Yeah, that one is simpler and it is easy to understand. That is what I'm saying. Moles is easier to understand, so it will be very easy for us to understand. So this, the only reason why they came up with the moles is for convenience and easy understanding. I'm imagining if they were giving you medicine, for example, I'm just using an example for easy understanding also. If they was giving, the doctor is writing for you, a prescribe medicine, na asiandike the amount you are given. For example, there is this medicine that we were given long time ago, malaria, the yellow one. I don't know if it is still working, if they still give out those ones, but I don't think these days hata watoto wapendi dawa sana. So there was that medicine that you were given that time. Imagine the doctor does not write, for example, 1 multiplied by 3. Yeah, how would you go home and take that medicine? Yeah, so I'm using that one to say the moles now was brought in so that I will know that one medicine has this amount of, let's say, the molarity, the concentration of the, let's say, the what to kill the disease. What can I use? What can I use? I'm looking for the term. There's a term I wanted to use. Let me just keep that one. Let me say it this way. Daktari ajue, we have medicine and we have the, yeah, we can use even bacteria. Or I didn't want to use bacteria because other diseases are caused by viruses. So if we have, you're supposed to take 3 multiplied by 1. But now the doctor knows that 1 has this concentration. For example, 1 mole of that anti-disease. Let me say anti-disease now. So lakini ndo hiyo disease itoke, we have to put 3 moles. But one medicine has 1 mole. So that is why you are given 3 multiplied by 1. That means you'll be taking 3 moles at once. So those are the things now. The molarity was coming so that it can make work easier for other people. Especially when instead of writing, you are supposed, I don't have to explain the concept or the molarities of the medicine. because I already know. But I will now, it will make me easier. Instead of writing 3 multiplied by 1 multiplied by, now so I don't have to explain the molarity. So that one is very important. So it was going to make work easier. That is, instead of saying, we have, hebu hesabu hizo mandizi. You say, I brought you a bunch of bananas. Somebody will know that it is ni mingi, sio kidogo. Or you say a dozen. You say, so instead of counting 1 to 12, you say a dozen. So somebody anajua automatically that is 12. A herd of elephants, that one means sio elephant moja ama mbili, ni wengi wamekuja. So it is making work easier. That is what so when we'll be talking about RAMs now, we'll be talking about the weight. So we'll be talking about the weight, the number of atoms, which is the Avogadro's constant. So those ones are very important. Sijui kama mnaelewa kitu before, that one is actually the introduction. I just wanted to explain the meaning of the mole, and how it came to be. So mole actually was not something that was always there. It came later on. So it is very important for people to know that. I don't know, I'm not very sure about the other system, if they were taught the mole, but it was something different. So the mole came in as a counting unit. I think later on, when they were now the international, is it international system of what? EU PACA of applied chemistry. So that one, at that time when they came in now, mole was now decided that it is the system international units, SI units now. Mole now was introduced. So previously the mole was not there. I think that time people were handling things. So mole is a very easy topic. That is the first thing that you're supposed to know. Ukishajua tu. Now, the way I've introduced this topic, you would think that you'll be having a lot of things to solve or a lot of things to remember. The only thing that you're supposed to remember here is the definition of the mole. And it is a counting unit, but we'll have a better definition hapo chini. So that is why I didn't say tushike hiyo. Yeah, we'll have a better definition. We'll have a better definition. I can even add something on the counting unit, but I would think we'll cut out the counting unit and say now as it is. So you don't have to cram the definition of the mole because we will use it. Actually, utaona hata wewe imetokea. When you see it, I will be solving it. You will be finding that it is actually the mole. Utakuwa unasema na hiyo ni moles, yeah, or how it is calculated. Relative mass. Now, the reason why we have brought about the relative mass, the second, the first objective, we were saying we define mole and its relationship with the mass. Now, it is called the relative mass because sometimes we'll be talking about the one that I've highlighted. Sometimes we'll be talking about the relative atomic mass, and then we have the relative formula mass. Na hizi vitu, especially the RAMs, we have an idea from the gas laws. The relative formula mass, we have an idea also from gas laws, especially when you're calculating the relative formula mass of gases. Kuna pale tulikuwa tunafanya RMM. You remember RMM where we are saying relative molecular mass? It is the same as relative formula mass or the relative molecular mass. It is relative mass. So we'll have those ones and the relationship with. Now, maneno ya relative mass, there's no problem when we use it. Now, I want you to remember, we have balances in the lab. In chemistry, most of the time we use the beam balance. Most of the time. Most of the beam balances are normally electrical. Yenye unaekelea ni kama the new, let me just say, ni kama the new weighing machine ya nyama. The one that we use to, when you go to the butchery, wachana na ile ya kitambo. Yenye walikuwa naeka some weights up. We have this new one that writes everything. You just have to change the unit. That one is the beam balance. But now your lab, it will be smaller. You will find that it is measuring maybe a maximum of 500 grams. So if you put something, for example, let me just mention that one. If you put something on the beam balance that is more than 500 grams. Give an example, 700 grams. You are killing that machine. You're killing that. So you don't. So those ones, I'm not going to talk about that one because there's something I'm interested in. Now, so we use the beam balance. I wanted only to tell you beam balance. So we use the beam balance. So beam balance, you reset. Let me just explain that one. A beam balance is normally something that is flat, like it is electrical. Most of them are electrical these days. I know we have the older ones, but most of the ones we use at the moment is electrical. Of course, tech coming in, and also it is easy to maintain. Now, ukiwekelea, for example, you want to measure the amount of substance. I want to use an example of mafuta ya kujipaka. Let me use Aramis, for example. Now, how do they measure Aramis without measuring the container, so that you have the content, the Aramis inside is, for example, 100 grams. So what we do when you're using the beam balance, I want to explain that one and then we move on. I hope you don't mind, because I want people to know. Maybe some of you also, if you also know how to use it, the better. For those ones who don't know, maybe you'll be given an interview. So the time the interview we were hiring a lab technician, and I gave him, the question was to measure, give me the measurement of 100 grams of something without removing the things from the container. So that is what I'm saying. So unaeka the container of the Aramis, that plastic unaeka juu ya beam. Yeah? Ukishaweka juu ya beam balance, it will have, si iko na weight yake, give maybe 10 grams. Juu iko na weight yake, you don't measure 110 grams of the solution of for example, of the Aramis that you're looking, of the solid that you want to measure. You tear down. There's a place zimeandikwa kwa hiyo, you tear down, ama unafinya tu ikuwe zero, Let me say unafinya ikuwe zero. If you tear down, it becomes zero. So the weight of the can, ama of the container that you are using, will not be factored in when you're adding your solid, or you're adding your mafuta. So you'll measure 100 grams of the solid after tearing down the weight of, or the mass of, the container that you are using. So that's how you use that beam balance. And it is very important to know how to use it, so that you don't waste time, because you want to keep time, especially when you're doing a practical. The practical of last year didn't have that one, but there is a practical, I think 2 years ago, they were told to weigh 5 grams. So we give you 10 grams of a solid, and then you are told to weigh, where would you be 5 grams. And most of the students messed up the molarities, or the concentration will change, because sasa hawakutear down in the beam and I know now nyinyi mko affected sana, because you don't have the teachers wenye wanawafunza kwa that exam center. So examination center yours, sasa hakuna mtu anaweza kuambia auja tear down ama akusaidie. So you must tear down. Unaweka container yenye ni empty. Let me say it that unaweka container yenye ni empty juu ya the beam, and then you tear down, ama ufinye ikuwe 0 that is tearing down. So you don't have the weight of the container becomes negligible. Alafu una you add now the solid that you want to measure up to the mass that you have been guided to. Ukishafika hapo, you remove that one, will be the actual weight that they are asking you to measure. So they didn't give you, but I remember I normally prepare everybody. So I think I'll also show you using a video of how you tear down, hata kama ikikuwa ngumu, you can go to, there's this simulation, it is called PET. Let me just write for you that one. Always the Costa Apple, and then you just saying use over beam balance. But I'll still share that one. I'll show you how it is used, because sometimes it is the science. It is this one is science. So I've written on the so that you can try. So I don't like people losing marks. You lose marks if you don't tear down. If you don't know how to use that beam balance, you lose marks, because the concentration will change. I'll show you how the concentration will change as we continue. Now, I hope you're okay. You'll use the FET simulation. I'll still use one. I'll try to use one. I'll try to log into my account and then I'll show you how it is done. Now, so when we are talking about the RAMs or the relative atomic mass, when you're talking about that one, there is how it was done. Previously, they used to use hydrogen. Now, we all know the mass of hydrogen. Kila mtu anajua mass of hydrogen ni 1. So kila mtu anajua ni 1. So it was easy. We were saying for you to calculate the RMs, this one is also done in Form 2. There's a place that you do in Form 2. For you to calculate the RM of, we were saying, because that's the way zijua. So scientists previously said, because the mass of hydrogen is 1, we can say the RM of an element is with respect to, so they were showing a similarity. They want to, not similarity, compare with hydrogen. So it was 1. And then they later on came to oxygen. Somewhere they came to oxygen. Now wakasema pia we can use oxygen. So they're saying, but now the problem with oxygen was maneno ya isotopes came in, the reaction and the rest. And then now they settled later on. This one is around 19 something. Sio kitambo. I think 1960s was there about. Now we came to the idea of carbon 12. So carbon 12 now is the one that is used. And this one now is normally explained better in Form 2. It is not the periodic. The second topic is it the chemical families or something? The second topic in Form 2 explains it better. How we normally calculate it. So when a mass of an atom is compared to that of another, it is called now the relative atomic mass. So originally, that is what I was saying. Kitambo kidogo, we were using this. We used hydrogen because it was the lightest element. What we were saying now, we are using it as an arbitrary value. That is in comparison to the others. Yeah, we are saying if you measure now, for example, the mass of sodium, we'll say now it is 23 times heavier than hydrogen. You can, because the mass of hydrogen is 1, and the mass of, so it was used first of all. So the relative atomic mass, which is our relative. So we are saying we are giving a relationship between two. Relative atomic mass. Relative. You know the meaning of relatives. So you have relatives. So you are related. Yeah? There is some blood yenye uko nayo yenye ako nayo. Yeah? So relative, we are saying we are comparing two things. We compare. For example, so originally it was, they normally asked this one. But I don't know, I don't know normally set an exam and ask this one. So they'll ask you what before using carbon 12, which one was, so that one, it is very important, which was used as an arbitrary value before now, before we came into the other one. So let me just explain, because this one, I know you have not done that topic in Form 2, but it is the same thing, especially where we are calculating the RAMs. RAMs, we'll be talking about that one. I think that one will come on later on. I don't know how you chose the topics to be taught, because mimi niliambiwa tu, they decided we are teaching this topic. So let us continue. So we have the relative atomic mass now is average mass of an element over the mass of one atom of hydrogen. So we are relating, and this one, remember, hydrogen is equal to 1. So for example, when I say sodium is 23 times heavier than hydrogen, or we can say copper is 207 times heavier than hydrogen. So that one was how it was done previously, which I thought this one was easier. This one actually was easier to use than the one that we're using now. But this one had also other issues. It had other issues. So, and then baadaye wakakuja wakatoa hydrogen na wakareplace na oxygen. Sasa oxygen ikakuja ikaleta shida ya scale due to the existence of oxygen isotopes. That is what I said. It was because of the isotopes. And then now in 1961, I heard it is in the 1960s, the other day, it's not long ago, the International Union of Pure and Applied Chemistry which is UPAC, recommended now due scale, a new scale which we were basing now on carbon 12. So carbon 12 now was chosen as a reference. There was a time the question was asked, why was carbon 12 chosen as a reference in the calculation of RAMs? Students could not explain. These are the reasons. So it is a stable solid. It is stable. Carbon 12 is stable. Carbon 14 is not stable. Now, despite the fact that we have isotopes in carbon, carbon 12 is very stable. Carbon 14, not really. That is why carbon 14, watu wa history wanajua carbon 14 inafanya maneno ya ku disintegrate. Is it called disintegration? Measurement of radioactivity. It's normally used to measure the age of things, because now it is not stable. It is not stable. But carbon 12 is very stable, which is the main carbon that we use. Hata kwa calculations huko carbon, nilikuwa naandika kweli C is equal to 12. It is not C is equal to 14. Because C14 is very unstable. So the reason number one, it is very stable. Reason number two, it is a very common element. So yani kila mtu mwenye ako above, let me say above 2 years or 3 years, ameshika carbon or something that has carbon. Everybody. Hata nyinyi, kila mtu, hata mtu ajui carbon anajua chakwe, which is actually amorphous carbon. So a dirty one. So it is common. Everybody can be enriched to the carbon. Yeah. So those are the two reasons that we chose now carbon 12 over the oxygen and over the hydrogen. Very important. Don't forget those two reasons. It is stable and it is also a very common element. This one is in the KLB. Now, the book that I will change to after we are done with the KLB might not really have these ones, but it is also very good for revision. That is, if you have some ideas. So after that, now what happened is we normally the carbon was assigned, but we are saying it is now 1/12, a 12th of it. Now I'll explain what happens up in. What we are looking for is for that thing to be 1. It is RAM, average of the atom, over 1, which you will see. So since the relative is a ratio, so because it is a ratio, we know that ratios do not have units. So RMs do not have units, but we keep it in our mind that the units that have been used in the measurement, kupima hizo vitu ni grams. We don't use, most of the time in the lab we do not use. So that is why unaonanga imeandikwa C. I'll tell you, I think we'll see that inaandikwanga C is equal to 12. They never tell you C is equal to 12 grams. The maneno ya grams inakuja sasa where we will be talking about the number of moles. We will be saying RAM, the mass, one mole is equal to the mass, which is now the relative atomic mass of that element. And then the mass now is in grams. Hapo sasa ndo introduce units. But otherwise, ujai pata imeandikwa, huwezi pata imeandikwa, for example, let me just write that one for other people. Huwezi pata imeandikwa C is equal to 12 grams. Or Na, which is sodium, is equal to 23 grams. Haiandikwangi hivi grams. It is only written 12 or 23. There's a reason for that. Because it is what? A ratio. The way this ikikuja tuweke grams, it is when now we are saying 1 mole of a substance is equivalent to the RAM, and the RAM is in grams. Sijui kama tunaelewa kitu hapo. Because that one is very essential. It is very essential. Of course, we'll do more examples. We'll do examples and then you see. So we can continue. I'm almost changing to the other notes so that we see. Hopefully it will be okay. So element, for example, RM of element is 1. That is the relative atomic mass of hydrogen. So previously it was 1, because now you see, let me just explain using this one. RM is equal to average mass of one atom. Huko juu ilikuwa hydrogen instead of atom of carbon 12. But it was not for 1/12 or 1/12. So ya huko juu ilikuwa tu over the mass of hydrogen atom. Which mass of hydrogen atom ni ngapi? 1. Now, when you talk about your carbon, now let me just tell you something about this one. What is, let me write so that it becomes easy. So for example, it is something. Let us use an example. We normally use sodium because it is very common. So you have sodium over, so mass of sodium now is equal to 23. So mnajua ni 23. When you weigh, you will find 23. But in relative to your carbon 12, it is 1/12 multiplied by 12, which is the Geneva. So when you cancel by 12, 1 by 12, 1. So you are finding that it is over 1 still. But with the reason for choosing this one is we wanted something that is stable. Now, I want you to remember that oxygen is stable, but at some temperatures, it becomes very unstable. It becomes very explosive. It can react with other elements, for example, oxygen. So we wanted something that was better, and that is why carbon. So, but in the long run, what we are looking for is, now I want to tell you this formula here, ERM, this one. Tafadhali kumbuka. This one actually is the definition of RM. Hivyo tu venye iko is the definition, the one that we mentioned on the, it is comparing the mass of an element with carbon 12. Yeah, that one is the definition of RM. So msisahau hiyo. So we'll have, now because we study the first 20 elements, it is very important for you to know these ones. Now, the only limiting factor about knowing the first 20 elements is the things kama kina lead, kina zinc, which normally comes in. So you are supposed to at least know the representation of those elements that are very common. We have kina iron. Iron does not fall under the first 20 elements, but you should know that it is called beryllium in the chemical name. So the chemical formula will be Fe rather than iron, which is Ir. Yeah, those ones. So you are supposed to know those ones. Now, so we have calcium, which is 20. Now, the RAM, let me just give you an idea of how to know RAM. I want you to go, when you go back to Form 2, there is this thing called is it called the atomic mass? Atomic number? Is it called the mass number? We have the mass number and something. I'm forgetting the other name. So number is normally the RAM. Most of the time, mass number is that is the combination of protons and neutrons. P plus N. I don't have atomic number. Yeah, an atomic number. Atomic number, protons peke yake. So RAM ni mass number. When you have now given what you call the ukienda Form 2, where we have the atomic number and the mass number. So you remember that atomic number ni proton. Mass number ni protons plus neutrons. Now, always remember that protons is equal to neutrons. No, protons is equal to electrons. Neutrons could be changing because they do not have a charge. So protons is normally positive, and then electrons is normally negative. So for that thing to be neutral or do not have a charge, the positive and the negative should be equal so that they cancel out. So I'm saying RAM is the mass number, which is mass number ni protons na neutrons. I don't know if you have mumefanya hiyo topic. I think it is done. Mumefanya. Have you done the topic? Maybe Opo or Mauga can answer because I can see them on the screen. Mumefanya the topic that
Tumefanya.
Yes, it is very important for you to remember hizo vitu. Mass number ni protons na neutrons. Atomic number ni protons peke yake. And protons are positively charged. But now most of the elements are normally neutral. So that means neutral means you have 10 positives and you have 10 negatives. So that you add 10 plus 10 minus 10 inakuwa 0. So you become neutral. So that one is something. Now I'm skipping that one because it is just an explanation. Because there's something I want to touch on, which is now actually the definition of the mole. Now remember nilisema huko juu tulisema mole is actually a counting unit, but we didn't say anything. Now when you come to the specifics, we'll now talk about the Avogadro's constant, which we'll do. We'll do even more examples, and I think the top match has more examples. Even the minus has more examples than the KLB, because now it is a combination of many. We also have the long one. I don't know, we can also use the long one, which has, of course, the long one now becomes a little bit tricky, especially understanding. That is why I'm saying KLB is very easy. Kama kuna KLB, it is okay. Now, so the number of atoms, I didn't want to select that one. I want to select this one. Mpaka hapo. I hope it works. It works, yeah. The place I have selected is the one that we are going to use in most of the calculations. So you say the number of atoms. No. So let me remove this one first so that it comes down. Yeah. So we have the number of atoms. The number of atoms in one relative atomic mass unit in grams of an element has been established to be. So when you measure, for example, 24 grams, let me use the one that we have been using, 23 grams. Let me use 23 grams of, let me just write it there. Because I didn't want anybody to feel like that thing I'm trying to remove it is not working as I thought. So the number of atoms in one relative atomic mass or one mass number in grams. You see now where the units are coming back. So we said RAM does not have units. But now we are saying now when we are talking about the Avogadro's constant, which is normally denoted by letter L, we are saying we use the units in what? In grams. So the number of atoms in one relative atomic mass. Na nimesema relative atomic mass, sometimes we call it the mass number. The reason I'm using the mass number is because of another class, but it is not for this one. Please don't misquote me. Nimesema mass number is the same as relative atomic mass was. Relative atomic mass. So there is no problem, but don't write it as in this place. I'm only explaining so that watu wajue mass number ni ile yenye tulitumia form 2 kusema actually what is the mass number of sodium? It's 23. What is the relative atomic mass of sodium? 23. So there is no problem. In grams, so the reason I'm saying this one is only for it is the units that are coming in this place. Remember, tukisiwa huko juu tulisema it doesn't have units because it is a ratio. But now when you come to maneno ya moles, we are saying that mass must be in grams and now has an established value of 6.023 multiplied by 10 raised to 23 particles. We have particles. Now, the particles in this case, I'll mention the particles. They have many particles. We have particles like atoms, we have molecules, ions, electrons, protons. All of them are considered as particles. Now, that number now, this number, which nataka, I don't know, this one is not, sio ngumu kuishika. You don't even have to cram it. 6.023 multiplied by 10 raised to 23 particles, which is normally referred to as the Avogadro's constant, which is normally denoted by this letter L. So mara mingi kwa equation hawatakuandikia Avogadro's constant, utapata imeandikwa L is equal to. When you talk about L, you must remember that it is the Avogadro's constant. Now, the definition of the mole that we are going to use now in our case, especially when you're given an exam, is this one. It is the amount of any substance that contains the Avogadro's number of particles. is the amount of any substance that contains the Avogadro's number of particles. What is the meaning of that statement? Now let me wrap so that I can explain the statement easily. Now it means 1 mole of a substance, any substance in that case, because that is what we are being told. 1 mole of any substance contains the Avogadro's is equivalent to the number of particles that thing has is equal to number 1. It is equivalent to relative atomic mass. That is number 1. We are using what we know, which is equivalent to the 6.023, and then you multiply by 10 raised to 20. So 1 mole of substances will have the RAM in grams, na pia iko na how many particles? 6.023. That is from the definition that we have gotten. So the actual good definition of the mole when you are defining in an exam room is useme it is the amount of substance that contains the Avogadro's number of particles. You come at sawa. I hope we are okay. Have you understood that place? Because that one is something that will, what I have written is very dangerous, because it is something that we are going to use all through. It's something that we are going to use all through, especially in the calculation. Because nilisema moles, actually what I am doing, we are just introducing. Leo tu tuna introduce. So we might not even have do most of the calculations today, but lakini after tumemaliza introduction, itakuwa tu we solve this. In fact, we can even do one question for 1 hour. I'm not saying the questions are hard because it takes a lot of time. I'm saying we'll do it very slowly so that people can understand. And some of the questions are very long, especially those ones when we be now in the titration part. They'll be long. Even the empirical formula we can do maybe, and the molecular formula, we might end up doing only maybe 3 questions in 1 hour or even 2. But the reason we are doing that is for people to understand. Ukishaelewa, you will solve the question. Empirical formula question normally only has 3 marks. So you will solve it. So that one is not the case for today. So know the definition of the mole, and you say it is the amount of any substance. Remember, definition of the mole is a unit, counting unit for measuring amount of substance. That is why it is here. It is the amount of any substance that contains the Avogadro's what? Number of particles. That is very important. Now, what is molar mass? We'll define some of those things. The mass in grams of 1 mole of a substance. So if you have 1 mole of a substance as the mass of that 1 mole of a substance in grams is molar mass. It is the molar from the name too. Mole, molar mass. So molar mass means mass in grams. It is given. There is a reason why it is written in grams. I normally like KLB now because of that case. KLB inaandikanga unit, inakwambia moles, the mass in grams, because sometimes we tend to, I don't know if we assume or we forget. So it is very important for us to know the mass in grams of 1 mole of a substance is referred to as molar mass. That is molar mass. So we already know the meaning of mole. We already know the molar mass, the meaning of molar mass. We already know the Avogadro's constant. Now, the Avogadro's constant, we know the number of particles. Now, if we know that, I think now we can give the relationship between the molar mass and the moles. Actually, we can give, which I had already given, that I had already given the relationship between the mole, molar mass, and L. Sijui kama watu wanakumbuka hata nilipeana. What is the relationship? Before I continue, what is the relationship between 1 mole, molar mass, and L? Because I already gave the relationship. The relationship is actually in the definition of those terms. Kuna mtu anajua that relationship before I continue? Somebody has an idea? of that relationship? So let me give the relationship again. Now, 1 mole, hapa kumbe tuko na nafasi mzuri. 1 mole, let me write in full. Don't forget, please don't forget this one. 1 mole is equivalent to the molar mass. And most of the time, let me just say, most of the time the molar mass is equal to RM. RM ile yenye wanaandika ile yenye umeandikiwa kwa for when you're doing the gas flows, tukifanya gas flows kuna yenye inaandikwanga in bracket. For example, C is equal to 12, N is equal to 14. Hizo, that one is the RM, which is equivalent to, so 1 mole has this amount of substance, and then nimesema L is equal to 6 point, so it is equal to 6.0. This thing, please, akimusisahau. If you forget this one, especially the first part, this one upper, we might not really have to solve the empirical formula and the molecular formula yet. But this one only normally is used to show us the, and remember, this one is particles. We have very many particles in chemistry. That is why I normally insist on writing particles. But particles, we have a lot. So they have mentioned for us atoms, molecules, ions, electrons, protons, and the rest. All of them are particles. Zote. Anything that we ever defined that time, it is very so particles. So this one now is the relationship between the mole, the molar mass, na nimesema molar mass mara mingi ni RMs, and it is normally given in bracket in the questions. So you don't have to cram that one. For example, upasi kukram maneno ya mass ya for example, lead, because lead is very huge, it is 207. You don't have to cram your mercury, hizo utapewa. Magnesium, they'll say it is 24, so you don't have to cram those ones. You'll be given, hiyo munapewa. So you don't cram that one. L, of course, sometimes you're given. So when you're doing a question, make sure that you have checked the values that you're given. Sometimes this one has been rounded off, by the way, 6.023. Make rounded off. So make sure that ukifanya exam, you confirm first. Some teachers are very tricky. They'll give you the non-rounded off one. Yenye ijakuwa round, you find that it is 6.02 something, 29 or something. Yenye ija roundiwa off sasa will give you a different answer with the one that has been rounded off. So it is very important to check those things. And that is what I've always been insisting. So completing the table, let us complete this table actually. Let us just try physically. We are not going to write, we are not going to write or we are not going to ask us. So we have hydrogen. Formula for hydrogen is, so nilisema lazima ujue formulas. In this one, you must know the formulas. If you don't know the formulas, you are finished. You are finished completely. So we have the formula hydrogen. For example, I'll skip it. I'll do the, what do you call it? The odd numbers. Let me do the odd numbers. And then the rest you can also try for yourselves later on. So we have hydrogen. The formula of hydrogen is H. Capital H. Tafadhali nataka muone sasa hiyo pia. I know there's some students who have been handling some questions. I don't know if she's in. Amekuwa akinitumia sana maswali, which is good. I've been marking for her, and she's doing a good job. She's doing a good job. She messed up the first time. The second time, she was doing a good job. Of course, I also stepped in na nikamsaidia na more methods of solving the questions, because alituma questions zenye ziko na more than one method, and she was doing a good job. I also checked that sometimes alikuwa na mess maybe writing the formulas, which is very dangerous. So for example, hydrogen is capital H, carbon is C capital, sulfur is S capital. Now, I'm not interested in those ones that have one. I'm not interested in those ones that will bring problems. For example, iron is beryllium. This one is in form 2. and now it is normally denoted by F and a small e. Calcium, it maintains its name, Ca. Nitrogen is N capital, and magnesium is M and G. I want you to see how it has been written. Make sure that these things does not touch. Zikutane, M na G zikutane, F na E isikutane, na E isikuwe kubwa kuliko F or isitoshane na F, yeah, ikuwe tu mtoto wake. Now the RM of this one is 112. Now there is a place I talked about molar mass and RM. I want you to see something. Now 112. What do you think is the RM of sulfur? Now I want you to see this one. What is the molar mass of hydrogen? 112. What is the RM of hydrogen? 112. What do you think is the RM of sulfur? Yes? Mauro, you're saying something?
Oh, sulfur is 16.
Yes. Sulfur is number 16. Yeah, I like this one. I think we are going back now to the roots itself. So, nilisema, what is sulfur is 16. What is that? Is it mass number or atomic number? Atomic number of or mass number? Now remember my mass number, the definition that I gave out, where I said atomic number. So it is okay. It is better even to go slowly na to jikumbusha what we were doing the other time. So
atomic number.
Atomic number. Now, nilisema most of the time atomic number is 16. And atomic number is protons, sindio? Now protons is equal to the number of electrons. Silikuwa sawa? Now, tukasema M ni mass number, which is protons plus neutrons. Iko sawa? Iko sawa mpaka hapo kila mtu. So atomic number, let me just write it here. Hata naacha niandike sasa. This one is big, eh? Atomic, let me use AN. Atomic number is equivalent to protons. Now protons in something is equal to electrons. Iko sawa? Now I am writing mass number. Mass number is equal to protons plus electrons. So anytime you see atomic number, it should be the smaller value. The bigger value is the mass number. So which is now nimesema mass number is also the RM. So if we have now the atomic number of sulfur to be 16, sorry. Now we must add another thing for us to get what? The mass number. And the reason I wanted to do that is, now I want you to see this one has 1 and the molar mass is 1. Carbon is 12 and the mass number is, the molar mass is 12. Now the molar mass of this one is 32. So actually the RM of this one also becomes what? Are you seeing the trend? 32. The mass number. Now when you talk about the atomic number, now there is sometimes they want to confuse us when you're talking about the mass number. They will tell you it is atomic mass number. It is the same thing, so you should not be worried. Atomic mass number is mass number. Atomic number itself is only the protons. Let me wrap this on. Munaelewa what I'm saying, so that people can, so that you don't fall short when you. So I want to wrap this one. So that one is 32. Now, from our definition, tukasema this one has how many particles? The one that, so we have molar mass have been given. What? How many particles will be given? How many particles is there in one molar mass or in a molar mass? The number of particles, it should be the Avogadro's constant, which is L, and L is equivalent to this value. I don't want to write. Now, let us continue. So this one again is 56. So what will be the molar mass? We can just solve all of it and then we see. Now we do a calculation, another one for calculation, then we see as the tukimalizia hapo. Yes. What is it the molar mass? What is the molar mass of iron, for example? Molar mass of iron? And then I want us to be together, what, so that in case can anybody, what could be the molar mass? We have RAMs. Remember when I was talking about the moles, I said 1 mole, let me just write it on top here so that it can help us in solving even the other equations. 1 mole is equal to the RAM. Na nikasema RM also is what we call the molar. It is the one that is normally given. Of course, most of us are not told. You are never, nobody will tell you this, but I'll just give you the RAM. It's equal to the molar mass. And that mole has how many particles? It has the particles L. And L is equal to 6.023 by 10. Let me write just juu tunatumia hapo chini, we'll do it hapo chini. So if you understand this one, then I'll be very good. Mimi, I think even so we are done with the sulfur. Iron, we are in the one that has iron. So iron has an RM of 56. So the molar mass and RM are normally the same. So that means the molar mass hapa ni ngapi? 56. And it has how many particles? The number of, that is atoms, it could be atoms. So it has the same L. Calcium RM of 40. So the molar mass is also. So these things they are the same. The only thing that will change is RM is a ratio, does not have units. Molar mass as units. Now I'll repeat that statement very slowly. RMs and molar mass are the same. The only difference is one of them is a ratio. So one of them will have units, another will not have one unit. So it is very important for you to know that. And so whatever you are normally given in the bracket is the RAM. Now, whatever you normally write in the question where you say 1 mole is equal to 40 grams, is you are saying 1 mole is equal to what? The molar mass. So it is very important for you to remember. And all of those ones have the same particles, whether it is calcium, whether it is oxygen. The only thing that will be changing is the mass. But the particles that are in it will be the same. Because now, for example, the mass of oxygen, now let me use the one that are here. The mass of carbon is 12. Yes. But it has how many particles? 6.023 by 10 raised to 23. Now, the mass of which one is the biggest? Iron is 56. Lakini particles ziko ndani zinatoshana na yenye iko kwa carbon. The only thing that will be changing is the mass, but the number of particles remains the same. So this one for nitrogen, what could be the, I don't know, nitrogen inakuanga number? What would be the mass of nitrogen?
Unasema hydrogen, teacher, ama nitrogen?
No, nitrogen. This one now, we are in this one. Let me circle that one. Nitrogen.
7.
7. Ni number 7, sindio? But when you add now, so it is normally number 7, which is 25. But the RAM now of nitrogen is not 7. That one is the atomic number. So you normally add, it has around, I don't know, 17 neutrons or something. So you'll find that nitrogen is normally number 7, is normally atomic mass of, unapata imeandikwa 17. Na hii pia ni, so I'm saying these ones, is it 17 or 14? So that I don't confuse people. 14, huh? I think it is 14. You just add the number of, you add the 2, so I think it is 14. Somebody to confirm. No, I'm not very sure. I think it is 14. And then this one also is 14. But remember, answers za huku zote ni the same. So 6.023. So upper PI you will find that it is 24. Magnesium inakuanga namba ngapi kwa the periodic table? I think it's around number 12. I think it is number 12. So that is why you
12.
find it is now 12. But the mass number, RM, is a double value. So it is very important for you. It is very important for you to remember. Yeah, I think nitrogen is number 7. You double that one. There is no problem, eh? Yes. Mumeelewa venye hii vitu inafanywa kabla sijatoka hapa. I just need somebody to say ameelewa. Because these ones are questions. Actually, these ones is just the introduction. Na itatusaidia hapo mbele. Before I do the, how many atoms are there in 1 mole of oxygen atom? So we can solve that one. Now, I want now to show you, this one now is the one that we calculate. How many atoms are there in 1 mole of an oxygen? So it is 1 mole of oxygen atom. So we know that oxygen inakuanga number. Oxygen inakuanga namba ngapi? If it is written, you can even go back to pale mlikuwa mnafanyia huko juu the gas laws. It is the same thing. Unapata oxygen imeandikwa is equal to 16. Most of the time it is equal to 16, eh?
8.
Yeah, it is normally 8. And then I said, because now that one is the atomic number, but we need the mass number. So it is very important for you to know. And that is why it normally brings confusion to students. Make sure you know that is why nimeguzia atomic number and mass number. So utapata imeandikwa hivyo. So wanasema how many atoms are there in 1 mole? So that means it is 1 mole. So that one is 1 mole. So you write 1 mole is equal to how many atoms? Of course, it is equivalent to 16 grams when it is an atom, eh? I think not a molecule. You know, this one I'm not saying molecules, eh? Oxygen molecule. They've said the oxygen atom. So that means it is 1. Is equal to 16 grams when it is an atom. Of course, when it is a molecule, it becomes 32. That is very important for you to remember. Which is equal to, so you can have atoms ngap, it is 1 mole of that one. It has how many? 6.023. 6.023 multiplied by 10, 23. You must understand how we come to be, or how that one comes to be. Yeah. So some questions could be inachanganya kidogo, but in the long run, this is what we are looking for. Now, there are very many methods of solving these ones, but we will use the simplest one. You will tell me. So I want to wrap this one so that I can move kidogo, and then we solve another question, and then you see how it is. I don't know if I think I need to leave now this one and go to something else, the other topic, but I normally like this one because I hope kila mtu, yani watu wanaweza elewa easily using the KLB than when we use another topic. But when I'll be doing revisions, I don't touch KLB ever. I want to use one that is a little bit easier, yeah, so that people can see. So I'll solve question number 4 because question number 4 is easier, so that we come back to the other one, eh? Now, so how many atoms are there in 20 grams of calcium? Now, sasa tumeanza kufanya calculation. So you see, I have not touched the molecules. If you can see, I have not touched the molecules. When we be talking about molecules, we'll be talking about something different. We'll be talking about something different. Now, let us solve this one. And if you have not understand, kama kuna pale hujashika vizuri, please don't keep quiet, eh? You say something. Now, so we say, how many atoms are there in 20 grams of calcium? Remember, we have been given RM of calcium, or the molar mass of calcium to calculate. So you remember that 1 mole of calcium equal how many, which mass? The molar mass is 40. 40 grams. That is why they said you should be having a calculator. This one now is where the calculator help us, which is as the how many values atoms. It has 6 point. Let me just write everything here. 23 by 10 raised to 20. It is a positive 23. That means it is a very big value. Lakini sisi tumepewa how many grams? 20. So you just equate. What about 20 grams? Itakuwa na ngapi? Then you cross multiply. Hii na hii. Hii na hii. The reason I'm writing this one is it will help us somewhere else. You will see. I don't want to talk about that one, but you will see. You will see where it will help us. So you will find that it is 20. Sorry. Yeah, 20 over 40. Yeah, multiply up and is 20 multiplied by 6.03. Sorry, 0.23. Multiplied by 10. 10 raised to 23. So this one actually will help us. Hii ndo itatusaidia especially, so you need a calculator for this because I don't think so. Of course this one is easy by 2 by 21 by 2 by 22. So you find that it has a value of 6.023 divided by 2 equal to, which is around 3 point. So the value is around this one. This one is the answer for that one, for the ear calcium. So how to calculate the mass in the following atom? You can still calculate the mass because you have been given now the RAM, which is
Teacher, please rudia hapo tena kutoka kwa
okay.
hapo. Itakuja nini? 20 divided by 40.
It is 20 over 40. Now let me rub. Can I rub it? Let me rub it and then I start it very well.
Yeah.
Can I rub all of it? Let me rub all of it. Yeah, it is good to say mapema than leaving it and then you later on you find it is becoming problems. Now let me rub it. Let me start. Now what I am saying is this: the RMs hapa wangeweka, what they have not given us in this case is CA ile sasa yenye inawekwa in bracket is equal to 40. So wacha tuweke bracket. This one is the only thing that I have not given. So we will know that 40 grams, the molar mass, that is what we said, 40 grams has how many values of how many atoms? 6.023 multiplied by 10. In fact, if I was in my school, I would not have touched so much on the theory part. In fact, I'll show you my notes and then muone kama ina make sense. What about 20 grams? In ngapi? Iko na how many atoms? Yes, and then you do this now. Cross multiply. Mwaura? Iko sawa? So you'll find 20. Yes. So it is very important for you to have a calculator when we're dealing with, especially the next, almost, let me say the only topic that we need a calculator in Form 3 is the two. Gas laws and the mole. After that, it will be theory. We have organic chem, sulfur, chlorine, nitrogen. So those ones are theory. There is no place that we'll be doing a calculation. But now this one, very serious calculations in Amalizo at the first term. So you will have now 20 grams. You multiply by 6.023 multiplied by 10 raised to 23 is over 40. And then the grams, of course, will disappear. The 0 will disappear by 2 1 by 2, 2. So it is half of this one. So what is 6.23 multiplied by 10 raised to 23 divided by 2? I think the answer will be, you'll find the answer should be something like this. I don't know. You can confirm, but I think that one is the answer. Iko sawa sasa mpaka hapo. Now let us do question 5. Let us do question 5 because I'm seeing question 5 is touching. I think I don't know if I think I'll end it earlier because I have to be somewhere by around 8:40. Very crucial meeting also. But we'll make up for the 30 minutes that are lost. I'll still take care of that 30 minutes. It will be easier to recover 30 minutes than to recover the whole hour. So I'll just rush. And 15 minutes is enough. It's not quite a distance. It is a school event also. That's why I requested for early. Now, can I solve question? I can solve 5-1 and then you try 5-2. That is okay. Yeah, and then I'll give you maybe. So let me solve 1. Of course, the teacher always solves the easiest one. I think mine is the easiest, but it doesn't even need a calculator. It becomes very easy. So they're saying calculate the mass in the following atoms. 3.0115 multiplied by 10 raised to 23 atoms of aluminium. And we have been given the RAM of aluminium. So we say 27 grams. This one now is the molar mass. RAM and molar mass. One has units, the other one doesn't have units. Remember that. Has how many particles? The Avogadro's constant, which is 6.023 multiplied by 10 raised to 23. Positive, eh? What about this part atom? So it has that amount of atoms. What about 3.0115 multiplied by 10 raised to 3 atom? Iko na mass ngapi? Yeah, that is the question that we're asking ourselves. So you do that. Iko na mass ngapi? That is the question. Calculate the mass. You cross multiply E, cross multiply with the one that we're looking for, and this one. So it becomes 27 multiplied by 3.0. But you're getting what I'm doing, eh? There's something I've left out. There's something that I've left out in this one, and I don't want that one to disturb you. That is why nimeanza hata kuitoa. Nimeona inaweza changanya watu dogo. Over 10, 23 atoms. I'm writing atoms so that people can see what I am doing. Over yote sasa 6.023 by 10 raised to 23 atoms pia. So the atoms go. What remains now is the mass, which is in grams. You see, it is in grams. So let me even write that one in grams so that people can never get confused. So we cancel this one by this one. This one is easy. By this one, need 2. So what is 27 divided by 2? It becomes 13 point.
Teacher, can you cancel the 10 power 23?
Yes, yeah, inaenda. I've cancelled everything. This one is one number. Actually, this one is one number. Na hii pia ni number moja. But when you're using a calculator, it is better. So you'll find the answer to be 13.5 grams. So hii ni number moja. Now let me explain this one very. Hii ni number moja. This one is a number. We are just, instead of writing 23 times. We are saying we are writing 6.023 multiplied by 10. Lakini in number moja. This one is one number. This one also is one number. Yep. So the answer to this one now is 13 point. Sijui kama watu wameelewa sasa.
Hiyo sasa tumeelewa. Mimi nimeelewa hiyo.
Now I'm giving you, I'm going at around 8:30 or 8 something. So let us solve question number. Can you write somewhere this question number 5.2? As I open the other book now, I want to open another book so that you can also try from the other book. Try very quickly. Write that one as I open another book. I want you to write fast and then I can open the other book. I can change. 12.046 by 10⁻³ atoms of iron, and you have been given the atomic mass of iron. If you're done, you tell me so that I can change. Are you done writing 12.046 by 10 atoms of iron? And we are looking for the mass, Looking for the mass. Yes. Please look for the mass for that one. And then
Teacher.
Monica, yes.
Yeah. You said we write.
I want you to try and solve the question 5.2.
Question 5.
2. The Romans 2.
Oh, okay. Let me write first.
Yeah, okay.
I'm done writing the question.
Okay, let me check. Now I'm changing. I'm removing this one. I'm stopping sharing the KLB, and then I'm sharing something different. So that we check something. I think somebody has shared the answer. I'll check. It's long one. I'm forgetting the name of the book I'm looking for. TQRS. Oh. Yeah, let me check. I hope everybody can see. So I've gotten one answer. So this one is the kind of empirical formulas. So revision exercise 1. Find the mass of the following. I'll leave you with these ones because I'm going to rush somewhere. Now, Monica, how long should I give you? Or are you done?
To get the answer. Teacher, there's some, kuna mahali ni kama sijanini vizuri. So, hii ilikuwako nini grams ya iron ilikuwako 56 ama?
Ni 56.
Eh.
So they have given you, I don't know what they have, it was iron, eh? So let me just solve it here and then I leave you with I'll just, I don't know, I think I shared the top notch. The top notch, I don't know now the page. The top notch, we have, you can open this question, revision exercise 1 in top notch. I think for the 30 minutes, you can still try the same. And then we can continue tomorrow. No, the next day, yeah? There's no problem. Let me solve that last one. So I can solve that one for you. The one that I gave out. So that, Monica, you can see how it is done. So I don't know, it was saying 12 points.
12.046.
46 multiplied by 10, isn't it?
10 power 23.
Yes, 10 power 23. I don't mind my handwriting here, atoms. And then they are saying we are calculating the mass. And then they have given us the mass, Fe. Is it? They said Fe.
56. Fe
Equal to
56.
Now, so nilisema this Fe now is the molar mass. Na tulikuwa tulisema molar mass, for example, 56 grams is equivalent to how many atoms? The L atoms, which is the Avogadro's constant, which is 6.023.
6.023.
Yes, 6.023 by 10 raised to 23. Yes. What about now what you have been given? Monica, uko pamoja sasa. What about 12.046 by 10 raised to 23? Ni ngapi? Ni mass ya ngapi? You see? And then you cross multiply this one and this one, and this one comes down. And the answer actually is what Maura gave us, which is 112, because this one I think is 2 moles, so it is like saying 2 divided by 56. I think that was the correct answer. Iko sawa?
Yeah.
Yeah. Wendo, I hope is you okay also, because now I can see only the 3 of you as at the moment. So I'll leave it at that for today. When we meet now tomorrow, no, also on Monday evening, hopefully I'll be the one taking you through so that we can complete now. I'll start with the relationship kidogo, and then we go now the calculation. So use the top notch page 19. Yeah, I have pages. In page 19, you'll have, you can try, and then you can send them to me even before we handle that class. You don't have to try all of them. Just choose revision exercise. You have number 1. And then you go, please. This one does not give us the, I have to pair the RAMs. So sodium is 23, lead is 207. Those ones. You can get it from the KLB. Just check it from the KLB. Chlorine is 30, 35, 5.5. Oxygen 16. Chlorine, is the same thing. Iron 56. Magnesium 24. Sulfur. You have sulfur 32. But try question, I think page 19. I think page 19 alone is enough. And then we'll use this one now on Monday to do more examples. So that one is okay.
Teacher, do you have the top notch in the group?
Yeah, but let me still share it, but you'll do it. I can still share it, and then you try those questions. For the 20 minutes, I think we can still recover the 20 minutes another time, so that I don't delay here also, and then I don't know to inconvenience you, because if I start something else, I might not really finish.
Okay.
Yeah, so that is okay. But I think we tried. I thought even I was going to leave earlier, but because I'll just go. I'll just make it in time. Otherwise, have a very nice day. Thank you for attending this class. Sorry for the inconvenience that I gave you in the morning. It's supposed to start at 8, but now we started earlier, which I know is tough, especially that it is the weekend. Thank you very much for attending. Have a very beautiful weekend. We meet next week. we start.
Okay.
So you can try. I'll still share the. So I'll
The
share
top
the top notes. Yes, again.
Okay.
Unless there's a
Thank you.
query.
No,
No,
let us thank you.
Yes.
teacher, on my side, no question. I'll try, then I'll send them to you. Just saying good day
Yes,
too.
please. And thank you, Monica, again for the good work you're doing. I'm marking a lot of your work. I think even I'm marking more of your work than my actual students in school.
Okay. I'm just
Thank you very much. Yeah, I'm very happy. Keep on trying. Yeah, you have a very nice day. Have a very nice day. We end it there for today.
Okay.
Okay.
Okay.